When's the best time to seal concrete?
Seal it, to put a concrete sealer on? Okay, so there's two answers to that question. As every question, there's more than one answer, but if we're using a cure and seal compound, then the answer is as soon as you can possibly put it on, because we need to get that curing as soon as possible. If we're going to seal concrete and we want to put a sealer on the concrete, then that will lead us and will help us decide what type of curing method we use. So when we talk about a curing membrane that we put over top of concrete, many of those membranes are a wax-based. Okay, so if it's just a curing compound, it's a wax-based curing compound. We cannot put sealer on top of that until we mechanically remove the wax-based curing compound. So the other product that we have available to us is an acrylic-based cure and seal. In that case, if we're using a cure and seal because we want to get it sealed, well, it's just like a curing compound. We want to get that on as soon as possible. But one of the things that determines whether or not this cure and seal compound will work well is what moisture levels on the surface. So if the moisture level on the surface is really high, that curing compound is not going to soak in, not going to attach itself to the surface of the concrete. So the answer really is we want to let that concrete dry out just a little bit so we can get that cure and seal on there. But because we're curing it, we want to get it on as soon as we can before it starts to dry out. Now if it's concrete that we've chosen to wet cure, so we've wet cure it for 3, 5, 7 days, we let that concrete dry out after that period, after that curing time, and then we put our sealers on it. And then the next question is, how often should we seal concrete? We should reseal concrete whenever the previous sealer is no longer effective. It really depends on the quality of the sealing job we did the first time, the quality of the material that we used, and the amount of traffic that concrete is seeing. But it's not uncommon to need to reseal concretes every year. Okay, that's a maintenance process. Sealing concrete is a maintenance process. It's not a one-time event. It's something that should be happening on an annual basis. How much concrete is actually being sealed annually? I'd say almost none. So we can talk about what theory says we should do and what's practically going on. But I drew that triangle yesterday and I talked about there's responsibilities for the concrete producer for making concrete last. There's responsibilities for the finisher and there's responsibilities for the owner. The responsibilities for the owner are to ensure that concrete is protected from the elements, and one of the ways to protect it from the elements is with sealers. Probably the only concrete that's being sealed on a regular basis is decorative concrete, because we want to keep that shine, that sheen to it, so that it displays really well. And if you have decorative concrete, you've seen decorative concrete, once that sealer starts wearing off, it starts looking pretty ugly. And the first thing you want to do once it starts going that way is you want to put a sealer on there to bring that sheen back so we can see those colors and see the vibrance of it again.
So if the sealer is just for protection from the elements, you have to see it when you seal inside buildings?
If there's no element, is there nothing going to be on that? I mean, what are we going to see on that? Well, we have oils, we have those other things going on the surfaces, right? But that said, we don't seal our concrete surfaces in our shops, so.
What about densifiers?
Surface densifiers?
Like, just expand the difference for a sealer and a densifier.
So what Tom's getting at, the question Tom's asking us, what about densifiers, surface densifiers? Now there's a number of densifiers that exist in the market. I think it kind of came up yesterday a little bit with a product that you apply with a squeegee. Well, there is surface densifiers, and there's different types and different chemical compositions of them. Where a surface densifier is designed to work is, and there's spray on, there's a squeegee on, there's a variation of them up there. The purpose of those, or the way they're designed, is they're designed to soak into the surface, chemically react with the free lime that's left in the concrete, and the purpose is to create more calcium silicate. which is the hard stuff in concrete. Which that does is densifies the concrete even more. Now it's not there just plugging holes with chemical. It's trying to chemically react with that free lime in the concrete and densify that surface. That's the purpose behind it. How well do they work? Well, you talked, and this is where you see me being really skeptical about some of the literature. I've talked to a fellow who used to sell these products, and when he used to sell these products, he used to sell them and tell people, I'm going to densify down 4 inches inside that concrete, and one pail is going to a 5-gallon pail is going to do 1,500 square feet. Do the math. How can you go down 4 inches? And how can you get that product to soak in that deep? So it just doesn't do that. What it's going to do, it may go down in a 1/4 inch, it may go down a 1/2 inch, but most likely it's only going to go in 1/8 of an inch and densify that surface 1/8 of an inch. So it is going to have an effect, but how much effect? Right? Are we gaining 50% densified surface? Well, there's not a chance. Maybe we're getting 5 or 10% more density in that surface. And are the economics there? But then the timing is important. The wetter that concrete is, the more moisture in the surface of that concrete, the less of that product's going to soak into that surface. So now we want that concrete to be dry on the surface. So we want to wait at least 28 days in a dry environment to make sure that we can get as much of that densifier soaked into the surface to get it as hard as we can. One more question? Sorry.
Car washes. How do you make a strong top so you don't wash out the top layer of concrete so you don't see those little pebbles start?
Okay, so a few things are going on, and so the question is, what about car washes? What are we doing in very difficult environments? How are we building a concrete for very difficult environments? Well, we're not really concerned with the traffic. Structurally, we're going to be okay. But in this case, what we're trying to do is get denser concrete on that surface. So one of the things that we can, and we have to balance that, but what we probably want to do in that case is we probably want to bring our water to cement ratio down. We don't want to increase our cement contents a whole bunch more because we're going to increase our shrinkage cracking. But we want to bring our water to cement ratio down as low as we can. Get us closer and closer to that 0.40 water cement ratio. We want to limit our, the amount of paste on our surface. We want to make sure we've got a good paste, but we don't want to over paste the surface when we're finishing it. And then cure, cure, cure. Yes? So surface hardeners or broadcast on hardeners, is that what you're asking? So the question is, what about hardeners on surfaces? What hardeners are designed to do is densify the surface, and the way they do that is by increasing the cement content slightly, but more often they're increasing the amount of hard material on the surface. So they're using a very, very hard aggregate that's being broadcast on that surface as well. And so that gets worked into the surface. So as it gets worked into the surface, we have a stronger surface. They're helpful, but we're finding more and more people don't want to use them, right? They're actually, finishers are refusing to use surface hardeners because they're so difficult to work with. And some of the things that have changed in our industry is our water cement ratios have changed so much. Now we're using, if you're looking for a 4-inch slump, we can give you a 4-inch slump with a 0.40 water cement ratio. We put a 0.40 water cement ratio in there, it makes it really difficult to use surface hardeners. There's no moisture there. Our moisture contents are low. And so it makes it even more difficult to work those in. And so if you are using surface hardeners, it's good to work with the producer and say, hey, give me a mix that I can use a surface hardener with. One of the other things that's coming out is more, what's it called, Albert? The internal hardener?
Hardchem?
Hardchem. You guys anybody heard of hardchem?
We did a shop floor, and we put the hardener right into the concrete. Into the mixer.
Mm-hmm. And so, I was told I was writing too small yesterday, so I'll try and make it bigger and bring this in a little closer. And if it was too small and you're still sitting at the back, it's your own fault. So, and so, when we look at a concrete, cross-sectional of concrete, what we end up with, and I think we sent that one chunk of concrete around. And you could see the densified surface just by tooling it. Now, if we had a densified surface with power trawling, a densified surface is going to be deeper and even more dense. And so what we end up with when we're power trawling is a densified surface. Okay? And when we're using surface hardeners, we see people putting surface hardeners in at the bow float stage. So they're bow floating the first application in. Then after they've broke it, we see them applying another one. I think historically they applied them a little bit later, but I think with our reduction in water cement ratios with our chemicals, they're needing to apply them a little bit earlier. But what that's doing is it's increasing the depth of that hard surface. Not only is it increasing the depth of that hard surface, but it's implementing hard aggregates into that surface. Okay? Now when we look at integral hardeners, and if we look at the data, and I've looked at all of the data for HardChem, for instance, because we've had customers ask us to supply HardChem for their application because they want a harder, they want a more wear-resistant surface. And so we've looked at the data for it, and when we look at their data for how much wear resistance, what they're really saying is, I forget the percentages, but it's a large percentage increase. Once it busts through this top surface, it significantly increases the durability. Okay, so what that's saying is that once your surface is off, it will last longer with an internal hardener. Because what it's doing is increasing the cement content and putting hard aggregates within the concrete. Now when we look at this product, it's a fairly pricey product. I don't know what it's running. Albert?
I don't know what the product is actually worth, but inland the bar can charge anywhere between 50 and 60 bucks a meter.
Okay.
How much you want.
So at 50 to 60 bucks per meter cubed. Okay, which works out to, okay, so if we have a 6-inch slab, we're taking that hard material and we're spreading it through the entire area. Really what's important for us, what we're most concerned with on a shop floor, is we're concerned with that top 1/8 of an inch. Its ability to resist wear, whether it be in a car wash or whether it be in a shop where we're dragging tools or dragging steel, where or in a silage pit where we're scraping it day in and day out. We want that hard surface, that wear surface. Well, with the HardChem, and yeah, I'm not on commission for HardChem here. I think you can tell. That HardChem is distributing it through the entire surface. And so you're getting $50 to $60 a meter and you're paying for it over that whole area. Whereas when we go with a surface hardener, and I do have some slides later on to talk about all this stuff, so we'll be able to skip over those. When talking about a surface area, we're putting that money in just to the surface where we want it. Okay? Now, when we look at value, I think the best value for your dollar is, first, manage your water to cement ratio. Keep your water to cement ratio low. That's your first value. Your second value is cure. Put yourself, if you're going to put this in through the whole surface, I would say, okay, now go give me a 3 or 5 day wet cure on that surface. Burlap it and keep it wet. Next value is your surface hardeners. Last value would be your HardChem. I think if you do all these other things, the HardChem has no value anymore. But really it comes down to good practices first. Your aggregates are going to make a difference. Whether or not you need to use surface hardeners, you need to be talking with your concrete producer and finding out what their microdevall numbers are. Microdevall is a test to determine the abrasion resistance of their aggregates. If they got very low microdevall numbers, then you may need to use surface hardeners. And you may need to use products like HardChem, depending on the application. But if your microdevall numbers are high, then what value is in there putting in more hardeners when you've already got really high abrasion resistance within your producer's aggregates. Okay? So again, it comes down to working with the producer. If you are the producer, work with the finisher when he's asking for these things and say, now look at my microdevell numbers, you'll see that this is probably not required. Okay? Yes?
Silage pits, how can we help from acid attacks in the floor?
Okay, we'll get to that. So don't, if I don't cover that by, say, lunchtime, bring it up again after lunch. Because acid attacks are something that we do need to talk about.